Okay, question number 18. P equals A over M minus X. X equals 8 correct to 1 SF. A 4.6 correct to 2 SF. M equal 20 correct to the nearest 10. Calculate the lower bound of M. Show you are working clearly. Okay, so first what I'll do is for X, A and M, all three figures, I'll be writing their respective upper bound and lower bounds. So they have said here X equals 8 and X is corrected to 1 SF. So X equals 8, it's corrected to 1 SF. So when I write the upper bound and lower bound, the correction has happened. 8 is written corrected to 1 SF. So the correction is happening to the second SF here. The second SF, so it's 8 means it's 8.0. So the second SF, the upper bound will be 8.5 and the lower bound respectively will be 7.5. Similarly, A equals 4.6 correct to SF. So A equals 4.6 is the answer corrected to SF. So when you're correcting to SF, your correction happens to the third SF. So the third SF, I'll mark it as a 0 here. So the upper bound value is 4.65 and the lower bound value is 4.55. So what this means is any number in between 4.55 to 4.65. If you correct it to 2SF, your answer will be 4.6. Similarly, in the X case also, any figure between 7.5 to 8.5, any figure in between 7.5 to 8.5, if you correct it to 1 SF, your answer will be 8. Then the next one, M equals 20 correct to nearest 10. So when they give you nearest 10, that's quite easy. What you do is you divide the 10 by 2. So you get a gap of 5. So what you do is M equals 20. You go gap of 5 up and 5 down. So when you go 5 up, you go 25. When you go 5 down, you get 15. So now we need to substitute the respective values here. P equals A over M minus X. So we have a division and we have a subtraction. So we need to be really careful here. We need to calculate the lower bound of P. Okay, so we need the lower bound of P. So first I'll focus on the division. Then I'll look into the subtraction. So in division, we know how we give our values. If I want the lower bound of P over here, then the numerator. For the numerator, we apply the bound we require. So I need the lower bound. So the numerator will get for the numerator, I will use the lower bound. While the denominator, I'll be using the upper bound of the denominator. So if I want the lower bound of P, I'll be using the lower bound of the denominator. I'll be using the lower bound of the numerator and the upper bound of the denominator. Okay, so now the lower bound of the numerator A, that's fine. A, I can get the lower bound, which is 4.55. But in the denominator, the upper bound of the denominator is M minus X. So how do I get the upper bound of M minus X? So what we do is for M, in a subtraction, what we do is again, the first person M, you give the bound that you require. So I need the upper bound of M minus X. So M gets the upper bound and X gets the lower bound. So this rule is applicable in division and in subtraction. So in division and subtraction, for the first person you give the bound you require and for the second person you give the opposite bound. So then we'll substitute the respective values over here now. So substituting the respective values over here, A, the lower bound of A is 4.55 over M. So for M, I have to use the upper bound. Upper bound of M is 25 minus lower bound of X is 7.5. So these are the values I need to just type in the cal now. 4.55 over 25 minus 7.5. So the answer is 0.26. So this is the lower bound of P. So lower bound answer 0.26.